Last night, you left your body. You wandered through places that don't exist. You spoke to people who are dead or who never existed at all, and then you woke up and got dressed for work like nothing happened. This is the strangest thing you do every single day, and you've stopped noticing it. You call it sleep, but something else is going on underneath. For thousands of years, humans assumed dreams were messages, gods, ancestors, warnings from beyond. That explanation feels primitive now. But here's the uncomfortable truth. Scientists still don't fully agree on why you dream. There are theories, there is evidence. There is no single settled answer. And that gap between what happens in your skull every night and what anyone can actually prove about it is where this story lives. Your brain does not shut off when you sleep. It changes shape. Around 90 minutes after you fall asleep, your brain enters a stage called REM, rapid eye movement. Your eyes dart back and forth beneath closed lids. Your heart rate rises, your breathing turns irregular, and most strikingly, your body goes limp. Neuroscientists call this REM atonia, a temporary paralysis that stops you from acting out whatever is happening in your mind. Your brain is running a full simulation. Your muscles have been switched off so you don't get up and walk into a wall. Why would evolution build something this elaborate, this costly, just to entertain you at 3 a.m.? One of the earliest scientific answers came from Harvard psychiatrist Alan Hobson in the 1970s. He proposed something called activation synthesis theory. During REM sleep, Hobson argued, the brainstem fires off essentially random electrical signals. Your cortex, the part of your brain responsible for meaning and language and memory, receives this chaotic noise and does what it always does. It tries to make sense of it. It builds a story. That story is the dream. Under this view, your dreams aren't messages at all. They're your brain's desperate attempt to narrate static. It's a humbling idea. The flying dream, the falling dream, the dream where your teeth crumble in your hand, none of it means anything specific. It's your mind doing damage control on noise, stitching together whatever fragments happen to fire. But that theory left something unexplained. If dreams are just random noise dressed up as narrative, why do they follow patterns? Why do so many people across different cultures and decades dream about being chased? Why does anxiety show up as showing up late or naked or unprepared for an exam you finished decades ago? This is where a different researcher enters the story. Rosalind Cartwright, a sleep scientist who spent over 50 years studying dreams at Rush University, found something Hobson's theory couldn't fully explain. She studied people going through divorce, grief, and depression, and tracked their dreams across months of nightly recordings. What she found was that dreaming wasn't random noise. It was emotional processing. People who dreamed directly about their painful experiences, rather than avoiding the subject even in sleep, recovered from depression faster than those whose dreams stayed vague or unrelated. Your dreaming brain, in her data, wasn't narrating chaos. It was doing therapy on you while you couldn't interfere. Think about that for a second. Every night, some part of you sits down with the hardest thing that happened that day and tries to work through it, without asking your permission, without waiting for you to be ready. This lines up with something else researchers have found about memory. Matthew Walker, a sleep scientist at UC Berkeley, has spent decades studying what REM sleep does to the emotional weight of memories. In his research, he describes something close to overnight therapy. During REM sleep, your brain replays emotional memories while a stress chemical called noradrenaline drops to its lowest level of the entire day. You get to relive the memory, but without the flood of stress hormones that came with it the first time around. Walker calls this a kind of emotional reprocessing. The memory stays intact. The sting attached to it fades. That might be why time is supposed to heal. It isn't really time. It's the dreaming that happens inside that time. Walker's lab found something else worth pausing on. People deprived of REM sleep for even a single night showed heightened activity in the amygdala, the brain's alarm center, the next day. Small frustrations felt larger. Minor slights felt personal. Without dreaming, your emotional volume gets turned up, and you don't even notice the dial moved. But emotional healing isn't the only theory on the table, and here's where it gets stranger. Some researchers argue dreams exist for a much older, much colder reason: rehearsal for danger. This is called the threat simulation theory, developed by Finnish cognitive neuroscientist Antti Revonsuo. He noticed that across cultures, across ages, across centuries of recorded dreams, the most common dream content by far is being chased, attacked, or threatened. Revonsuo argued this isn't coincidence, it's training. For most of human history, the single biggest threat to survival wasn't disease or hunger. It was other predators and other humans. A brain that could rehearse escape again and again in a low-stakes simulation while the body lay safely still might respond faster and more effectively when a real threat appeared. Under this theory, your nightmares aren't malfunctions, they're flight school. You are, in a very real sense, still training for a world that mostly stopped trying to eat you thousands of years ago. So which is it? Random noise your brain narrates into a story? Emotional therapy running in the background? A survival simulator rehearsing danger? The honest answer is that these theories aren't fully at war with each other. They may be describing different layers of the same nightly event. Your brainstem may fire chaotic signals. Your cortex may build them into a story. That story may lean toward threats because threat detection was evolutionarily non-negotiable. And along the way, your mind may use the same machinery to metabolize whatever emotional weight you're carrying that day. Here's what almost never gets mentioned. You dream more than you think you do. Studies using brain scans and sleep labs suggest most people experience several distinct dreams per night, sometimes 4 or 5, cycling through roughly 90-minute intervals that get longer as the night goes on. You simply forget almost all of them. Within 5 minutes of waking, half a dream is typically gone. Within 10 minutes, most of it has vanished completely, unless something, an alarm, a partner shaking your shoulder, a sudden noise, jolts you out mid-scene. That means your mind is generating an entire nightly world, night after night, decade after decade, and deleting almost the entire archive by the time you've brushed your teeth. Somewhere in your skull is a library larger than anything you've ever read, and you burn it down every morning without knowing what was inside? What would it mean if that archive wasn't deleted? Some researchers who study lucid dreaming, the rare state where you become aware you're dreaming while still inside the dream, suggest the boundary between waking thought and dreaming thought is far thinner than it feels. In lucid states, people report being able to influence the dream's direction. Fly. Change the scene. Confront the thing chasing them. If a sleeping brain can be steered even slightly by awareness, then dreaming isn't simply something that happens to you. It may be closer to a different mode of thinking altogether, one your waking mind rarely gets access to. Children, interestingly, don't dream the way adults do, at least not at first. Researchers who study children's sleep have found that dream reports before around age 7 tend to be static and simple. A single animal, a single object, with little of the narrative complexity adults describe. The storytelling machinery of dreaming appears to develop alongside language and imagination themselves, as if dreaming isn't a fixed biological reflex, but a skill your brain grows into, the same way it grows into speaking in full sentences. There's also the question of what dreaming does for skill and memory, separate from emotion entirely. Researchers at Harvard once ran an experiment where participants spent hours learning a maze on a computer screen, then took a nap. Some of them reported dreaming about the maze itself, seeing its walls, its dead ends, its turns, even though they had never physically walked through it. The ones who dreamed about the maze performed significantly better when tested again after waking. Their brains, it seemed, had kept working on the problem after the screen went dark, running practice rounds nobody asked for. This shows up outside the lab too. Athletes and musicians have long described dreaming about their sport or instrument the night before a big performance, and waking up feeling strangely more prepared, as if their hands or their legs had already rehearsed the motion. Neuroscientists now think this isn't superstition. It may be the same overnight rehearsal system Revonsuo described for danger, borrowed for skill instead of survival. Your brain doesn't seem to care whether the thing it's practicing is running from a predator or landing a jump shot. It just practices. And then there's the strangest wrinkle of all. Not everyone dreams the same amount, and not everyone remembers dreaming at all. People who suffer damage to a small region near the back of the brain, the parieto-occipital junction, sometimes stop dreaming entirely, even though their sleep otherwise looks normal on every measurable scale. This tells researchers that dreaming isn't simply a side effect of sleep itself. It's generated by specific, identifiable machinery that can be switched off while leaving everything else intact, which raises an uncomfortable question. If dreaming can be surgically removed from a person without touching their sleep, what exactly were they losing along with it? So what does this mean for you? Tonight, when you close your eyes again? It means the version of you that shows up in dreams, running from something, crying over someone, flying above a city that doesn't exist, isn't a glitch in the system. It's your brain doing several jobs at once, rehearsing danger it hasn't seen yet, processing pain it hasn't finished with yet, and narrating chaos it can't fully explain. All of it happens while your body is paralyzed and your conscious mind is switched off, which means the most complex psychological work you do all day might be happening in the hours you least remember. You spend roughly a third of your life unconscious, and in that unconscious third, some other version of your mind is awake, working, rehearsing, healing, without ever asking you what it should do next. Tonight, you'll leave your body again. You'll wander through places that don't exist and speak to people who aren't there. And when you wake up, you'll forget almost all of it. But somewhere in that forgotten world, some part of you was working something out.